In northern Namibia, there are a couple of very deep caves that happen to be water-filled, and divers have explored these caves to significant depth, but they're running into the limit of human physiology with depth that they can dive. And also the passages are so huge that even when they're down there, even though the water's crystal clear, they can't see the walls. These places are unmeasurable by humans. The goals of the Dragon's Breath expedition are to take a small underwater vehicle, an autonomous underwater vehicle, an AUV, that we've developed at Stone Aerospace, and send it into these caves, Dragon's Breath and Harisib Cave, and use sonar to map these places that humans can't see and dive the robot beneath depths that humans are able to explore. So our goal with Sunfish is to create an autonomous underwater vehicle that's capable of working in really complex environments. Places that we've had it before include Antarctica. We've taken it underneath the sea ice outside of McMurdo Station. We've had it in lakes around our lab in Texas. We've had it in Peacock Springs in Florida. Now that's another flooded cave system, but it's quite shallow. It's a very popular cave diving site. Maps exist. It's more labyrinthine, but it's all known. And so we're able to compare the map that the robot has made against maps that exist of Peacock Springs. Coming to Harisib and Dragon's Breath is a very different situation, even though it has similarities to these previous environments that we've operated in. This just kind of ups the ante. So we're planning to go much deeper here. The passages are much, much larger than Peacock Springs, so I think that's going to require a different kind of exploration strategy than the robot has used before. From the surface down to the bottom of the cave at Harisib is about 100 meters. Almost all of that is on rope. So we're rappelling up and down. There's about 800 pounds of dive gear that has to go in here for any emergency recovery dives, allowing us to observe the robot with divers.
At the moment, all we're going to do is just get this down to the water's edge.
And that's just the dive stuff. On the robotics side, Sunfish itself is about 100 pounds right now. It's a prototype, it's still heavy. In addition to that, we've got probably another 200 pounds of fiber, tools, rafts, stuff we need to operate down there right now. Unlike an ROV is a remotely operated vehicle. Sunfish is an AUV, an autonomous underwater vehicle, and what that means is that Sunfish can explore on its own.
Yes, the vehicle is in the water.
Mission Control, let's do a thruster check. Looks good. We do have a fiber optic data link from our mission control station down to Sunfish, and we do that for a couple of reasons. Sunfish is capable of exploring on its own, but we're still developing some of those exploration behaviors. So what we do is give Sunfish a set of behaviors to perform autonomously, and then we watch over its shoulder via that fiber optic link to see how those behaviors worked out.
Sunfish is at 60 meters depth. It's proceeding down the chimney.
Inside the vehicle are about 400,000 lines of software that control autonomous behaviors, meaning robotic behaviors that it does on its own. And so it can, for example, by itself, without us doing anything, explore into an unknown cave. And that's what we're doing here.
We haven't really pushed the depth limitations of Sunfish so far. So in Antarctica, we took the robot to maybe 20 meters. Lake Travis in Texas, we've gone to maybe 70. Peacock Springs was certainly less than that. Here, we really want to work at depth. So the divers have told us that they've been down to about 130 meters. They've seen down to maybe 150. Part of our goal is to push beyond what they're able to do physiologically. So here, we're working with a depth limitation of 250 meters, and I'm hoping we'll go that far, and it certainly seems that the caves have the potential to do that.
Sunfish is at 133 meters. We have good DVL lock on the bottom here.
Deep as that vehicle's ever been.
Okay, we're gonna start accumulating depth pretty quickly here. Let's keep an eye on that. Yeah,
Where are we at?
207 and heading down.
Yeah. Everything was going great, you know, and it's those kind of things that in the back of your mind, particularly as a cave diver, you know, you don't go too far before you kind of look over your shoulder to see what's behind you. You know, it might surprise you, you know, like it's gone to zero visibility or something. You know, so when I look at this, it's like everybody's getting excited, and we're seeing, I mean, we had just discovered a gigantic new chamber down there, and we were starting to go deeper, and we figured, all right, it's not going to be much further before we hit the structural depth limit of the vehicle, which was 250 meters. And so we were actually expecting within minutes to hit that number and say, okay, that's it. I had glanced over at the head-up display, and there's a series of numbers there that I knew what they were, and the one that I was looking at was depth. And suddenly it stopped and put up a number that said NaN, which means in computer speak, not a number. And I immediately froze, and I looked at Neil and I said, oh, geez, we may have just lost the vehicle.
State estimation is down.
We have lost control of the vehicle.
You know, within 30 seconds, we had gone from this euphoria of going, all right, hey, this pit is going down. Where's it going? Let's go see, you know? And then the next one was this cold feeling coming up your spine of, we may have just lost a $750,000 vehicle.
All right, like we're discussing options here. Right now we have restarting the state estimation only, which is something we've never tried before. Using the joystick thrust mode, which is hard to control, or shutting down the whole ROS system and bringing it back up.
Did it implode? Did the vehicle simply implode because we had made a bad calculation and the implosion depth was lower than what we thought? Did it run out of power? Did it, you know, what happened? Nobody knew. We had a depth sensor triggered a failure of the operating system.
We are seeing telemetry data now.
Luckily, they were able to reboot the vehicle. The problem then is it came up basically mindless. It didn't know where it was, it didn't know which way it was pointing. Normally, it had this map that it had built, and it would just zip right home along that map. Well, now they had to do the whole thing over again. Why is that a problem? Because the power was dropping down, and so the clock was ticking. The sand was running out of the hourglass, and these guys now, under pressure, had to explore back.
We have now made it back to the horizontal section at roughly 170 meters, and we are transiting through the large chamber that we saw on the way down.
The mission control guys were able to drive the robot back out, but it was a stressful journey the entire way. The exploration of Hauracib was a success on multiple fronts. This is the largest chamber we've ever mapped, it was the deepest we've ever gone, and now we feel that we're ready to go on to Dragon's Breath. Today, we take the robot into Dragon's Breath Cave. The road's bumpy, there's a lot of gates. There are several factors that make Dragons probably a lot more challenging than Hauracib. For one, the logistics of just getting in there and working in there. The place where we launched the robot from is going to be a lot more remote than it was in Hauracib. Some well-traveled fiber. It's going to be a lot harder to get all of the equipment all the way down into this cave.
Hook your cow's tail into the taut line, rappel the slack line, take you right to the platform.
If you find yourself in a position where you don't have a pulley, you can still do it with your cow's tail carabiner. Getting Sunfish into Dragon's Breath was difficult. The robot barely fits. There are some spots where the walls are really close together and you're pinched. It was difficult to slide the robot through some of those cracks.
So I'm holding the whole vehicle weight right now. I can't hold this forever.
Yeah, well, right now we're stuck. We got to do something quick here.
Pass it back to you. I've got it this way.
So I'm going to lift up and give the load to you. All right, stop there.
Got it.
You got it? I got control here.
Very good.
While you're moving all of that stuff, as a caver, you're also attached to ropes. You've got harness, you've got stuff hanging off of you all over the place, and you're trying to move this heavy equipment through these tiny places and pass it on to the next person. It was a lot of work. So we've shuffled all the gear down into the cave. Sunfish is in the water. We're ready to do the dive, and there's no communication to the surface.
So these lights are on, shows we're working on the top. These lights are off, show it's not working on the fiber. There's a fiber optic cable that's going all the way down into the cave to talk to both the people down there and most importantly to the Sunfish robot. And right now, we're not getting any communications over that. So right now our only form of communication is getting people to go up and down the cave.
Until this connection is completed, nobody is able to do any work.
Is that stressful?
Yes, it is very stressful. One way to check the connectors on this fiber is to have somebody shine a light from one end. I see it. We got light. Well, that means that the fiber is, so far, appears to be working correctly. So we're gonna plug it into mission control and hopefully it will work.
All right, let's see if this works. We have connection. Woo!
All right.
As the robot went into the descent phase, as it started to enter this tunnel that was 175 meters across, the map that was showing up was incredible.
We are now at 95 meters.
There were these boulders on the floor the size of houses. The ceiling was kind of this rounded face with all of these boulders along the floor. And the dimensions still just stayed huge. Kind of down a gentle slope, not like Harisib. Harisib was a shaft. This was a long slope that eventually pinched out at the bottom. Sunfish's ascent out of Dragon's Breath was fantastic. The robot navigated its way out using its maps. It came right back to the home position. From an engineering standpoint, that's exactly what we want to see. The exploration of Dragon's Breath was a success. We learned a lot. This is the world's largest underground lake. It's enormous. We thought it was maybe going to go for kilometers. There was that potential. That's not what happened. But we did learn how deep it goes, and we did learn what the shape is, and that it's not connected to other things. And that's useful information as well. The lessons that we've learned exploring these caves here in Namibia have definitely brought us closer to some of these other exploration goals. The ultimate dream for Sunfish is to send it to an ocean on another world. In our outer solar system, the moons of some of the giant planets actually have liquid water oceans underneath icy shells. One of these is called Europa, and there are several others. There is a lot in store for Sunfish. I think this is going to be just the beginning.